some people listening are saying, well, if I know that I need microservices, ultimately, shouldn't I just start there? Absolutely not, no. Why do I say that? Because, again, microservices solve problems that when you're small, you don't yet have. And of course, as with all things, they introduce new challenges. So
introduce a lot of complexity, a lot of cost, which you don't want to pay unless you really need it.
Exactly,
right?
exactly.
Good morning, Randy.
Morning, how are you?
Good. So, a few months back, I was in London at a conference, and I saw a talk by you. And one thing that I remember very clearly is that you met Mr. Gorbachev.
Right, I did say that.
So tell me about that.
Oh, wow.
That's an interesting story.
What
How
a
did
great
you
way.
end up meeting Gorbachev?
Oh, what a great way to start. Yeah, so a thing we can talk about in detail if you like was that my first love was not computer science, or it was political science. So I actually have a degree in that, and was very interested in doing law and international relations, so I was always very interested in that. We can talk about why I ultimately went to computers, which I'm very happy about. But anyway, Gorbachev was my personal hero, so remember, well, why would people know this? I went to, when I was in university, it was 1986 to 1990. So that was, certainly the beginning part of that period was still the Soviet Union and the US and the Soviets, battling it out for world domination. And Gorbachev was such a breath of fresh air. He's not, I think, maybe as well respected in his own country, but from the outside, wow. So many things happened that could have been much worse with tanks and all, and I think in lots of ways it was his influence and probably his direct orders, to be honest, that made it so we can be in beautiful Budapest and not not have had a war. A big hero of mine personally. So he came to visit Stanford, where I went in my last year there, and he gave a talk. And we were in the, I was, in the audience of the talk, but then also afterward, he sort of, waved to the crowd as world leaders do, and I got to shake his hand. So that was a big deal for me.
Yeah, that's, I believe so, and I think Gorbachev is pretty much underappreciated here in Hungary as well, because, they were an oppressing power in Hungary, so
look,
pretty obvious that any leader of that country would be.
You know this, I know you know, but how should we do? 1952, 1956, 1968, not just here, but in the Czech Republic and all over, the Soviets put down freedom, uprisings, resistance, whatever words you want to use, but anything there. And boy, 1989 could have been that. It was, they certainly had all the power to do it, all the people and all the preparation. And like I say, I think it's very much due to Gorbachev that we have peace. Now.
It's amazing that era has ended, and it has ended so long ago that the Berlin Wall has been fallen down longer than it stood by now. So it was last year. Right? Yeah, it was last year that it was already longer period since it has fallen.
Oh, that's gorgeous.
Since the entire time it stood.
That's right. 1961 it went up. 1989 it came down. 28 years. Yeah, fantastic. So I lived in West Berlin when I was in university. So the early part of 1989, while the wall was still up, and then after that, again, this is because I wanted to study East-West relations. That was my personal passion in international relations. And so so I did a quarter of study, 3 months of study in West Berlin at the Free University there, which had a relationship with Stanford. And then after that, I actually went to Krakow in Poland, which was, as we did say, behind the Iron Curtain, right? So on the on your guys' side, on the communist side, and so both of those experiences were wonderful, and they were very intentionally intended to juxtapose the two. Do you know what I mean? Like very intentionally, one quarter in the West, surrounded by the wall, understanding what that was like and experiencing it directly, and then going to Krakow and experiencing, what you and and your compatriots and everybody here in Eastern Europe was experiencing too.
Yeah, and actually it was a really exciting period when the switch happened, because I remember really vividly. I was like 10 years old, but the changes that went through in this area, things like walking in the stores one day and seeing all these identical packagings and having shortages of everything, and then a few weeks later you have all this Western stuff, like everything changed in a few months. It was a very interesting period.
Wow.
So, yeah.
How exciting to have
those are one of my those are probably my earliest memories.
Wow.
Other than a few glimpses from my childhood, but the first really sharp memories are related to that switch.
Wow. Yeah. And again, just to underline so much, that transition, let's use the right words, like the end of an empire. Usually that is followed by civil war and real war.
Peaceful. It was really peaceful.
And it was,
except for the Balkans, right? That was a carnage, but...
Yeah. So I'm not an expert in that area. And also, it was related, but I think there are some particular historical things about Yugoslavia that made that happen. Again, I'm not an expert, but my understanding from friends of mine that had lived there and actually studied that area, so friends of mine in college who've then gone on to be experts in international relations and professors and so on, that Yugoslavia was a combination of peoples that really didn't, in retrospect, we learned they didn't get along very well.
Yeah.
I guess, and more so than I think a bunch of the other nations, if that makes any sense. Like, it was more... not uniquely, but maybe more than the other of the countries, more artificial, if that makes any sense. That particular combination, I don't know. Again, that's not my personal area of expertise, but yeah, and very sad and terrible. But
so after you were in Krakow and in West Berlin and did all this political science stuff, you eventually ended up becoming a developer and working at pretty high-profile companies as a pretty high-profile person, like eBay, Google, and lately we worked at Stitch Fix and now at WeWork, I guess.
WeWork, as of 2 weeks ago.
So you were like VP of things all around.
After a while.
After a while. But so how did all these political things influence your career later?
Oh, that's a good one. I should take two seconds and describe why I made the transition.
Okay.
So my first idea of my career, which I had since I was maybe 13, was that I wanted to be an international lawyer, because all these, maybe you can hear it already, like I'm really, particularly at that time, I was really passionate about those areas, and would it be possible to bring peace and to, have people work together instead of fighting each other and having nuclear weapons and stuff. So I was really passionate about that area and wanted to see what I could do about it. There's a longer story as with all things, but I ultimately ended up after I graduated from. Okay, so while I was at university, I studied political science, like I said. But I also had a long-term interest in math and computers. My father was an early pioneer in computer science. He worked
what a pioneer indeed.
Yeah, hard to live up to and fantastic. He worked at Xerox PARC, where they invented Ethernet and object-oriented programming with Smalltalk and the laser printer and graphical user interfaces.
And he was working on FPGAs. Right?
Yeah. So what he did, interesting. Yeah. So he didn't. He got his PhD in computer science in 1970 in one of the very first computer science PhD programs in the United States, and therefore probably in the world. Like, I don't think it was the first one, but it was pretty close in the world. So his PhD was in 1970, from what was then called Carnegie Institute of Technology. Now we call it Carnegie Mellon University. Anyway, so he graduated, had his freshly minted PhD. His doctorate, or his thesis, was actually on what we now call FPGAs. Then it was called reconfigurable computing, because he proposed this idea. Like, it was proposed in his thesis. And so if you look at the papers that people write about FPGAs now, you just trace the graph of the papers back. They terminate at my dad's thesis in 1970 because he proposed this idea.
Okay.
He was actually trying to solve the problems of rapid testing. That's how could you test new chips, because that was a real problem in the 60s. And he thought that if you build a chip that was reconfigurable, that was just basically didn't already have the pathways in there, but could be somehow configured from the outside to change and add the pathways, that it would work. And my mother typed you can actually go look at this thing online, which I did recently. But like my mother typed it on their typewriter because, of course, they didn't have word processors and stuff. That wasn't invented until Xerox PARC a couple years later.
Yeah.
Anyway, so he worked at us, so that was his thesis.
I just wanted to add one thing here.
Please.
Because there is something in common with the two of us, and one is that I didn't plan on being a developer,
cool.
And I wanted to be a rock musician, but
Nice.
but it was my father's influence partly that I ended up being here.
Oh, nice.
Because he is a developer as well. And one more common thing, probably not many viewers know that you are of German background,
Yes.
and I am too. Because my father is of German descent.
Oh, cool.
Yeah, so
Oh, nice.
so I can understand your pain about the German attitude.
Oh, yeah. Yeah. So, right. So many different things to say.
Yeah.
Along that line. So my last name Shoup. It's misspelled.
Okay.
We spell it S-H-O-U-P. That's not the correct spelling. In German, it would be S-C-H-A-U-B.
Yeah.
And the Germans are going, oh, now I get how to spell it. That's a pretty common, that's a not uncommon name in the German-speaking regions. Yeah, so both sides of my family are from the German-speaking parts of Switzerland. So my mother's family is from Einsiedeln, which is outside of Zurich. And then my father's family is from Basel originally. That's where the Shoups, my line of Shoups, comes from. And then we have other relatives, that are from all the German-speaking areas, right? Western Germany and Aachen, all sorts of, all over. Regensburg, all over the place. Yeah, so, and as is common when people migrate to the U.S., so my family's been in the U.S. for about 3 generations. They migrated in the late 1800s, 1880s. All of my great-grandparents were from outside the United States. But then all of my grandparents were then born in the United States. And they very rapidly lost the German. So I suspect that the great-grandparents spoke with the grandparents, but the grandparents never spoke with their kids and really just very much became American. But as you know from the talk, but I'll share with the listeners, what's the way to say it? The culture, the Germanic culture, and just the way of being, that's still in my family. And I think people don't even, my family doesn't even fully realize where it comes from.
Yeah.
But the more that I work with, I'll say proper Germans, like people that have lived in Germany and never left, there's such commonalities among just the duty, the discipline, just the how you're just not supposed to complain. And yeah, these are all things that are just very familiar from my own family. And it's not really good or bad. I think it gives me a lot of personal strength, and also sometimes, you wish that maybe you got praised a little more for doing nice things, but if you do what's expected, like, you're not supposed to, like, that's just what's expected.
Yeah.
You know what I mean? Like, you do what's
I know exactly
I
what
know
you
you
mean.
know. Every German is like, oh yeah, I know exactly how that goes. Yeah.
Yeah, I mean, it's exactly like that, especially with my grandmother, because she's completely German, and she's like the archetype of a German woman.
Yeah.
Like, really diligent and lunch has to be exactly at noon, like
Oh yeah.
like clockwork.
Yeah.
But anyway, let's tie it back to how these experiences shaped your career as a developer.
Yeah, sure. So, popping back up to the, so again, my dad was at Xerox PARC. Again, so he did the FPGAs in his thesis. He actually never did that as a career. Other people took that further, which was great, fine by him. He did computer graphics, though, at Xerox PARC. And so his work was one of the first paint systems. So if you've ever used, I don't know, Microsoft Paint or anything like that, all the metaphors are exactly from my dad's system in 1973. So you've got a palette of brushes and you choose your color, and do you want an ellipse or a line or, you know, fuzzy or pen or something like that, and then you have a canvas that you draw on, and that was exactly the system that he built in 1973. And then that inspired one of his collaborators there, a guy named Alvy Ray Smith, went on to co-found Pixar with Ed Catmull, and so they took computer graphics and animation a lot further from there. Anyway, so that was in the background for me, and I always liked math and computers. And when I went to Stanford at the time, they didn't have minors. I'm not sure if Europeans are familiar with majors, minors. So we have in the U.S. system, you typically have one major, which is your main course of study, and sometimes people can optionally choose to do what's called a minor, which is a kind of a certificate more than a degree in some other thing. Stanford didn't have that, but I did want to study math and computers in some semi-serious way, and the only way that I could do that, in addition to the political science, was to get another major. So I actually have 2 degrees, one in political science and one in, it's called mathematical and computational science, so basically applied math. Anyway, so I had that as a degree when I graduated, and I knew that I would ultimately be an international lawyer. That didn't happen, but that was what I thought I was going to do. But I didn't want to go straight to graduate school and study that, so instead I worked for 2 years as a software engineer at Oracle, because that would be fun, and you know, I would enjoy it, and you know, hang out with my friends a little bit, have some money, and then I would go to grad school. So I did that for 2 years, and I did go to grad school. So I started going to the law school at Stanford, and then I was also going to do a joint program with another school called the School of Advanced International Studies at Johns Hopkins in DC. Anyway, so long story short, I ended up deciding that I didn't want a career in international law, mostly because there is no such thing as international law, I discovered. And also, I guess a little bit thankfully, because if I wanted to have a concentration in arms control and like reducing nuclear weapons with the U.S. and the Soviet Union, like that career path ended.
By that,
that already happened, so I wouldn't have helped too much. Anyway, so but fortunately, you know, when I was going through this crisis of, well, I thought I was going to be an international lawyer and now I don't want to be, I had this software development in some sense to fall back on, and I remembered how much I really enjoyed it, and so I ended up leaving the program after that graduate program after 1 year, and then going back to Oracle and working there for another 4 or 5 years. And then after that, I went to some other companies, one called Tumbleweed, which was for security software with large enterprises and banks, and started actually doing distributed computing there with Corba. And we built our own application server in C++, so not sure I recommend C++ and Corba, but I learned a ton doing that. And then went from there to, where did I go from there? Informatica briefly, which is a like ETL data movement company. I don't know how they would say it now. And then I went to eBay and was there for about 6.5 years. And so learned a lot about building distributed systems at scale and all that. But as with all things, so it's funny, I was literally tweeting about this just before you picked me up. But I never studied distributed systems. I don't even know if there was a course in it, to be honest. But if anybody is like earlier in their career and feel like, oh, you know, I can't do X thing because I didn't study it in school, you can learn it on the job. Like none of this stuff is rocket science. Do you know what I mean?
Yeah, absolutely.
It's all, I mean, well, there are a few areas of computer science where you really, really need a depth of knowledge, but those are very few and far between. And again, people pick it up. And if you didn't study it in school, no big deal, because guess what? Most of the people that are a little bit older didn't study it in school at all either, because there aren't that many people that took a deep learning course. in college.
Exactly.
I mean, they could have taken neural nets, that was around, but then they probably forgot about it for the most part because nobody was practicing neural nets until 5 or 6 years ago.
Exactly.
In industry.
Exactly.
And it was, I mean, I had nothing to do with this, but like thanks to Andrew Ng's work and Jeff Dean at Google and figuring out how we could actually parallelize some of these algorithms, like now they're all a thing. Anyway, so people who are now, even great experts in machine learning, maybe none of them even studied it,
Yeah.
Anyway.
And it's actually, even deep learning is pretty easy to pick up if you had a background in math. So.
Yeah. It's funny, I was saying the other day at another conference, I mentioned just in passing that I was a math major. Somebody, I asked at the end, does anybody have any questions? And one guy's like, what kind of math do you do? I'm like, well, I do computers. That's not a lot of math. I mean, if you have a math background, like we multiply things maybe a little bit.
Yeah.
If you're doing machine learning, okay, there might be a derivative here and there. But that's kind of it. I mean, in terms of even, I won't even call it advanced math, even intermediate university level math, like we hardly do any of it. That's all right.
So going back again, you were working with distributed systems, and you have been talking about microservices a lot at conferences, right? And I just wanted to ask, what do you think are the most important aspects of microservices? Why and when would you use?
Oh, that's great. Yeah.
Because I think that sometimes people are overusing microservices. That's my personal opinion.
That's my personal opinion too. I think there's a real tendency in our industry to look at what the big companies are doing and saying, oh, well, if Google does this or Amazon does this or Netflix does this or something like that, it must be good.
Yeah.
And that's not really right. It's not that they're doing bad things, of course. Obviously, it was working for Google. But guess what? Google has 30,000 software engineers.
Yeah.
I'm not saying 30,000 people in the company. 30,000 software engineers in the company. And obviously, Google's pretty incredible. I worked there. I loved it. I learned a ton. But stuff that works at Google scale is not appropriate for most of us, which are maybe three orders of magnitude smaller. You know what I mean? 30 developers or maybe 300. So, I mean, I do talk a lot about microservices, but I always try to begin with microservices are a solution to a scaling problem. Scaling of your team, scaling of the load on your system, scaling of your customer base.
Exactly.
And if you do not have those scaling problems, you don't want to use microservices. So ultimately, you want to know about them because maybe ultimately you should be so lucky that you have a huge team and you have a huge customer base and so on. And knowing that those techniques exist in the world can help you to recognize, that you have other options. You don't have to invent it yourself like Google had to do or Amazon had to do, 15 years ago. So I'll just start from if you're not sure whether you need microservices, you for sure do not.
Yeah, and actually I think that for most companies, microservices should come around by breaking down the monoliths, right? So you always start with a monolith because at the beginning it's perfectly fine.
Yeah, exactly. And some people listening are saying, well, if I know that I need microservices, ultimately, shouldn't I just start there? Absolutely not, no. Why do I say that? Because, again, microservices solve problems that when you're small, you don't yet have. And, of course, as with all things, they introduce new challenges. So
introduce a lot of complexity, a lot of cost, which you don't want to pay unless you really need it.
Exactly, right? Exactly. So what you can do, for the people that are skeptical, like, oh, well, I know I'm going to be fantastically successful, and ultimately I'm going to have 30,000 developers in my company. So
95% of the time you are not going to be.
99.9, but yeah, sure. I'm with you there. So the thing you can do, though, I do strongly believe you should start with a monolith. By the way, why do I think that? It's because that's how eBay started, Twitter started, Amazon started, Netflix. Every company that you have heard of and respect now has gone through multiple iterations of their architecture. In eBay's case, they've completely rewritten all of eBay 5 times.
Mm-hmm.
5 times.
Wow.
And that's not because they were idiots. It's because they did a thing, it worked well, then it didn't work. Then after several years, you know what, the business has grown or changed in a way that this isn't the right thing to do, and we do a different thing. Anyway, so definitely start with a monolith. So how do you get to microservices? Well, first you recognize that the monolith isn't working for you. Maybe, and the reasons why people might consider abandoning their monolith for microservices would be, I like to say, feature velocity. So it might be that if what you're experiencing is that you have a monolith and it's so tightly coupled or spaghetti code or intertwined that everybody's kind of slowing down, like the teams are stepping on each other's toes, or another warning sign is if you bring a new developer into your company and it takes them months and months to become productive, or more precisely to be safe, oh yeah, sorry Randy, you really need to wait 3 to 6 months to check anything in because you don't know what you're going to break, because everything's so intertwined. Well, if you have that situation, yeah, we do need to solve that problem, and microservices is one potential way to solve the problem. But even within a monolith, you can build a componentized system. Right? So microservices are components separated by process boundaries and maybe a network. Do you know what I mean?
Yeah.
I know you know, but like microservices are a distributed system, out of your thing. There are ways of getting a lot of the benefits of that by componentizing things. And every with only a few exceptions, all of the common programming environments have some concept of a composable unit that can be inside the process, right? So a jar file or a DLL or a Ruby gem or whatever programming environment you use, you have some way of typically expressing some unit, and that unit has an interface around it. And with most, certainly with the statically typed languages, you can protect the interior. Do you know what I mean? People only, use the interface and don't violate that boundary. That's a great way of getting a lot of the componentization and team parallelization benefits, even if what you deploy is actually one process. And by the way, that's how all stuff was done in our industry before relatively recently. There were... why didn't I take a distributed systems course? Because nobody offered one. That wasn't a thing, Did they build distributed systems? Sure, but not very many of them. I went to college when Erlang was being even developed at Ericsson, right? That was 1986, if I remember correctly. It was really a very, telecoms, it was military. I mean, there were only a very few use cases for what we would truly call distributed computing. Anyway, so there you go.
Yeah, so I completely agree that it's just not necessary in most cases. And why would you pay for something that you don't need?
Yeah, exactly.
And actually, sorry, one thing that that ties in really well here is the Spotify model for product management, right? So a lot of companies are trying to adopt that model exactly the way Spotify does it. But here's the bad news: you are not Spotify, and that goes for almost everything. That goes for agile practices, goes for distributed systems, for product management. Whatever you do, it's not enough to copy word by word what other companies and other people have done, because you have a different context.
Yeah.
And what you should really worry about is not trying to, copy something that worked somewhere else. What you should worry about is finding your own best way of doing things.
Yeah.
And for that, I think the scientific method is a really good approach. You start by something, and then you try to adapt to the learnings that you have.
Yeah, exactly. Yeah, everything, as we all know, everything is context. What's wonderful about the modern about the world in 2018, though, just to add to what you were saying, is we can learn from what Spotify does, what Amazon does, what Google does. We don't have to, we shouldn't slavishly copy it, for sure. I strongly agree. But the wonderful thing is, we don't have to, if we should understand our context and we should try new things. And also, once we have an understanding of our context, we can look for other places that maybe have similar contexts, which can give us hints about things that might work.
Yeah.
You know, so you can say,
you can learn from the concepts. Yeah. But one thing that I see happening a lot is for example, with Agile, that they have these very rigid Agile frameworks like Scrum, and they adopt it word by word and don't question anything. So what you end up with is something that you can call Scrum, but without the soul of Agile, right? So you just do the stand up, but you don't know why you do it. So it won't be about what it should be about. You do the retros, but you end up blaming each other pointlessly. Stuff like that. So you always have to question what you are doing and why you are doing it. And it's not enough to copy something that worked for somewhere. Someone.
The incredibly sad and outrageously ironic thing is, in Agile, as you know, which is what you're saying, Agile was all about think for yourself. If something works, do more of it.
Exactly.
And so the outrageous irony is that the vast majority of people that are practicing, and Agile was a reaction to the previous terrible, overly rigid, overly structured, not thought through, context-free processes. And so the terrible and horrible irony is that most people that think they're practicing Agile are actually just practicing some hollow copy of a thing that worked in some random other context, not theirs, 20 years ago.
Yeah.
Since we're at CraftConf, people should now, I'm sure that when they're watching this will also be available, but Dan North, a great friend of mine and a wonderful practitioner of Agile and testing and all great things, he has a wonderful talk, which I think he's delivering here, which he calls Swarm Scaling Without a Religious Methodology. And what he's talking about is, it's a bit of it's exactly a reaction to, Scrum, like all these rigid Agile processes, and what are ways that we can actually practice, like regain what's interesting about Agile without being, religious. In other words, without being overly structured and didactic and, context-free. Anyway, so, he's a great thinker and is great. Has a wonderful humorous way of pointing out the ironies and, and hypocrisy.
I love the guy. I absolutely love Dan North.
But I don't want to get too cynical, but what I will say is, as with so many great ideas in our industry, a lot of them get co-opted by consultants or companies or both, and turned into these very cookie cutter things when they really should never have been cookie cutter. Yeah, it really bugs me.
That's a really good point. That whatever process you start to come up with, once you want to monetize it, you have to put a framework in place, because otherwise it's not monetizable, right? You can't monetize saying, hey, here is the 5 steps of the scientific process, and you just do that, and the idea.
How do you monetize?
You can't monetize.
Do what's
that,
right for you. Yeah. No, it's a lot easier to monetize. Here are the 10 things that everybody should follow, and I'll be very happy to sell you my books and my services and my training.
People don't want to adapt Agile, and people don't want to adapt microservices. They want to buy it. That's the.
Oh yeah, right. Yeah, right. How do I buy my way out of my problem? Well, but the other thing is, and again, I don't want to be too cynical about it, but it's hard to think. Thinking is hard, but you know what? You have to actually think. You got to think about your architecture. You have to think about your process. You have to think about your culture and your organization, and anybody, including me, by the way, who comes and tells you there's only one right way to do it is wrong. And you shouldn't trust them. You shouldn't trust them.
Yeah.
Yeah.
So, thank you very much. I really enjoyed this discussion.
Me too. This was a lot of fun.
And we are just about to go to craft, so that's great.
Perfect timing. All right.
Yeah.
Thank you so much. This was great.
Thank you. Bye-bye.
Bye.
Thank you for watching this episode. I hope it earned your subscription. But while you're here, let me show you something. The people behind me are playing a game called Lean Poker. It's a fun and exciting way to learn how you can deliver value much faster than you have ever imagined. It's exciting. The link is in the description. Check it out if you want to support this channel.